Our focus for this class is arithmetic progression, and then sometimes it can be written as AP, and in some cases it is known as the linear sequence. Okay, so an arithmetic progression is a sequence in which the increase or decrease, otherwise known as the common difference between any two consecutive terms, is the same throughout. What do I mean by this? Let us consider the sequence 5, 11, 17, 23, 29. Okay, how do we know if this sequence is an arithmetic progression or not? The only way you can know is to find out the difference between each of the terms. All right, so the difference between this 5 is otherwise known as the first term. This is the first term. This is the second term. This is the third term. And 23 is the fourth term. Finally, 29 is the fifth term. So in this particular sequence, we have 5 terms. So we said, how do we know if this sequence is an arithmetic progression or not? The only way to check is if T2, okay, this first term is denoted as sometimes A or T1, okay? So 11, which is the second term, is T2, while the third term is T3, the fourth term T4 and T5, and so on and so forth. So 25th term will be T25. Is that okay? So the difference between the second and the first term, which is T2 minus T1, must be the same thing as the difference between T3 minus T2 must be the same thing as T4 minus T3, and for this sequence must be the same as T5 minus T4. So if this is the same, and then we have computed correctly, then we see that we can now deduce that this sequence over here is an arithmetic progression, because the decrease or increase in the consecutive terms of this sequence are the same throughout. Is that okay? So when this occurs, then we say that the sequence in question is an arithmetic progression. Another example we can consider is, let us say we have 24, we have 15, we have 6, we have minus 3, we have what? Minus 12. Let us say this is another sequence we want to consider. Let's check if it is an arithmetic progression or not. And how do we check? Is if T2 minus T1 is equal to T3 minus T2, which is equal to T4 minus T3, blah, blah, blah. That is, and so on and so forth. Okay, so let us check. 15 minus 24, will it give us the same thing as 6 minus 15? Will it also give the same thing as minus 3 minus 6? And will it give the same thing as minus 12 minus 3? Okay, let's check. 15 minus 24 is equal to minus 9, which is equal to minus 9, yes, which is equal to minus 9. And this is equal to minus 12 plus 3, which is also equal to what? Minus 9, because minus times minus will give us plus. So we have minus 12 plus 3, which is also equal to minus 9. Therefore, we can conclude that this sequence is an arithmetic progression, otherwise known as the linear sequence. Okay, all right, so this is just the introduction to the arithmetic progression. Of course, the common difference can either be positive or negative. It can be fraction, it can be whole number, it can be decimal. Okay, like we saw here, it was negative in this sequence, while in the first sequence we can see that it was positive, and the common difference for the first sequence was 11 minus 5, which should be equal to 17 minus 11, should be equal to 23 minus 17 equals 29 minus 23. This gives us 6 is equal to 6 is equal to 6, then is equal to 6. Then since they are all the same, we can conclude that the sequence is an arithmetic progression. Do not jump into conclusion that the sequence is an arithmetic progression or not. Is that okay? Unless you tried each of the terms, the subsequent terms, to confirm if they are all the same thing. Is that okay? Except it's a continuous sequence. That is, if this sequence has dot, 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 then we assume that the sequence follows the same pattern. Is that okay? Because sometimes they might want to confuse you, and then probably this, when you subtracted this from this, it gave you 6, and then subtracted this from this, it gave you 6, and then you might decide to subtract this from this, probably it gives 7. So for the fact that these first two terms gave us 6, okay, we shouldn't just conclude that it is an arithmetic progression until we check to the last term. Is that okay? So this is where we'll draw the curtain for this class on the introduction to arithmetic progression. In our next class, we are going to consider the nth term of an arithmetic progression.